So here is day 2 of our overview of factoring quadratics. Today we are going to look at factoring using the area model, also known as factoring by grouping, and then factoring trinomials where the leading coefficient, the value of a, is not 1, where it's greater than 1. So we've already done distributive property, we've done greatest common factor, we've done difference of squares, trinomial with a equals to 1. So today we're going to do area model and trinomial with a is greater than 1. So let's start out by looking at this 4-term quadratic. There is no greatest common factor, so there's nothing that will go into all 3 terms. But if we notice there are 4 terms, so we can use an area model to rewrite this quadratic. So I'm just going to place each term in the blank area model form. So I'm just putting each one of my terms there. And what I'm actually doing is I look at these 2 terms here, and I see that they have a 2 and they have an x in common. So they both are divisible by 2, and they both have an x term. Then I look at these 2 terms, and I see that they're both divisible by 3. 3 will go into 3. 3 will go into 12. So I'm going to bring out a common factor of 3. Then I look at these 2 terms and see that they don't share anything but that x in common. And then I look at these 2 terms and see that they share a common factor of 4. So then I can know that this factors to be x plus 4 times 2x plus 3. Notice this looks just like it does when we multiply, way back at the beginning, when we reviewed that multiplying. But we start out with, we started out with these, and we filled in the ones in the middle. So what we just did was we filled in the ones with the middle, and we worked backwards towards the ones, the factors that we multiplied to get our original expression. Because remember, factoring is writing an original expression as a product. So now we can write this expression as a product of 2x plus 3 times x plus 4. So here's another example. We're just going to take each one of these terms and fill in the inside, 3x squared plus 6x plus 4x plus 8. And we look to see what they have in common. Those 2 terms, a 3 will go into both of those, and they both have an x. These 2 terms, a 4 will go into both of those. These 2 here share an x, and these here share a 2. They're all plus signs, plus, 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 so I know that this must be 3x plus 4 times x plus 2. Or you could just as easily write it as x plus 2 times 3x plus 4. All right, let's try one more together, and then I'm going to leave you some time to do these on your own. We've got 9x squared plus 6x plus 12x plus 8. And we look to see what they have in common. They share a 3x. These 2 terms I can divide by 4. These 2 terms I can divide by 3, and they also have an x. And then these 2 terms share a 2. So then I can write that as 3x plus 4 times 3x plus 2. And when I multiply that out, I get 9x squared plus 6x plus 12x plus 8. All right, take a few minutes on your own and try, actually let's do one of these that's got a minus in it. So let's do this last one. I'm going to fill in 3x squared. This is just a little different because it's got a couple of subtractions in there, but it works pretty much the same way. These two terms, they are divisible by 3. A 3 will go into both of them, and they both share an x. These two terms both share a negative. They don't share anything else, so they have a 1 in common. So they have a negative 1. These two terms share an x, and these two terms share a 2. So then this is going to be 3x minus 1 times x plus 2. And that's the factored form of that one. Just take a few minutes on your own and try a few of these, and then double check with the answer key as you feel comfortable. Here, since these are both minuses, I know that this has to be a minus, and this one also has to be a minus. So it's going to factor to b. Same with this one. Since this is a minus and this is a minus, both of those have to be subtractions. All right, so these are, they're easily factorable by the area model because they are already divided up into 4 terms. And so they fit nicely into the 2 by 2 boxes here, and it makes it nice and easy to factor. But in reality, what this really was, if we go back to, if you notice that we can actually combine these two like terms. So that's really 3x squared minus 7x minus 10. That factors to this. But we had, this had already been expanded for us. The negative 7x had been expanded and rewritten as 3x minus 10x. So we're going to use that for the next set of problems. So we're going to use the AC factoring method, which we learned on day 1, and this area model factoring to help us factor quadratics when the leading coefficient is not 1. So right here we have a leading coefficient of 2 instead of 1. So what we want to do is we want to start out identifying our A, B, and C just like we did. A is 2, B is 7, C is 3. And we want to find two numbers that multiply to give us 6, 2 times 3, that add together to give us 7. So multiply to give us 6, add to give us 7. And that is, hopefully you can see that that's going to be 6 and 1. Think about that. 6 times 1 is 6. 6 plus 1 is 7. So you'll hear me talk about that as being our magic pair of numbers. So that's going to be 6 and 1. And then what that helps us do is we rewrite the 7x using that 6 and 1 that we found over here. So we're going to expand that 7x to be 6x plus 1x. Now we have 4 terms, and now we can fill in our area model just like we did a minute ago. And then we look to see what that row shares. We see what that row shares, this row or column, and this column. And so the factored form is x plus 3 times 2x plus 1. So again, we're combining the AC method that we learned on day 1, two numbers that multiply to give us A times C that add to give us B, and combining that with the area model or factoring by grouping to factor that quadratic with the leading coefficient that is not 1. So let's try another one. So we're going to identify A, B, and C. We want two numbers that multiply to give us 24, that add to give us 10. So first we need to think of all the ways we can get 24. So that's 1 and 24, 2 and 12, and 3 and 8, and 4 and 6. All of those will multiply to give us 24, but only 4 plus 6 gives us 10 when we add. So that must be the magic pair that we're looking for, 4 and 6. So we're going to rewrite this 10x as 4x plus 6x. The 3x squared stays, and the 8 stays. And then we look to see what they have in common. They share an x, they share a 2, they share a 3x, and they share a 4. So our factored form is x plus 2 times 3x plus 4. It's going to be really helpful if you are pretty good with your multiplication facts at this point. It's going to be very helpful. If not, that's why I've given you the factoring grid that can help you with that. I'm going to go back up here and grab that right here so that I can use it again as we're doing these that get a little trickier. I'm going to paste it right there. All right, so now let's look at this one. First, we're going to make sure it's in standard form and identify A is 4, B is 16, C is 15. Well, I want two numbers that multiply to give me 60, 15 times 4, that add to give me 16. So I need them to multiply to be 60 and add to be 16. So let's go up here and see if we can find ways that we can multiply and get 60. So I have a 60 right here, 6 times 10. I have a 60 right here, 6 times 10. I know that 2 times 30 is 60. I know that 3 times 20 is 60. 4 times 15 is 60. 5 times 12 is 60. All of those are ways to multiply and get 60. But the only one that adds up to 16, like I need it to, is 6 and 10. So that must be my magic pair, 6 and 10. So this is going to be 6x and 10x. And then I have 4x squared and 15. So really I'm just breaking this up to be 10x plus 6x. And these two share a 2x and a 5. These two share a 2x and a 3. So this factors to be 2x plus 3 times 2x minus 5. All right, let's try one more, and then you can get some practice on your own. Let's do, this is the exact same one, so I'm gonna make up another problem here. Let's make this 4x squared plus 13x plus 10. So 4x squared plus 13x plus 10. I don't know if this is going to work. We're going to try it. I don't think it will. Nope. Let's try it. I can just write it here. Factor 4x squared plus 13x plus 10. There we go. All right, so we're going to factor that one together. And I know my 4x squared is going to go here, and my 10 is going to go here. Now I need A. A is 4, B is 13, C is 10. So I need two numbers that multiply to give me 40, that add to give me 13. So I'm going to go back up here, and I'm going to look to see where my 40s are. So I have a 40 right here, a 40 right here, 40, 40. So I have 10 times 4. That adds up to 14, so that doesn't help. But then I have 8 times 5. And 8 times 5 is 40, and 8 plus 5 is 13. So this must be 8x and 5x. So my magic pair is 8 times 5. 8 times 5 is 40. 8 plus 5 is 13. And then I factor. What do they have in common? These share a 4x and a 5, and these share an x, and these share a 2. So that gives me 4x plus 5 times x plus 2. And that is how you factor when your leading coefficient is not 1. You've got 3 more that you can try to do on your own. And then we'll move into the review.